yesterday. And yesterday we learned 3 methods for graphing straight lines. What we're going to talk about today is the one that I find students do the most, like they want to do it by default, even though I tell them there's easier ways. And that method is you solve for y, and then you do the slope-intercept method, right? So in this example up here, we have x minus 2y equals 6. If I want to get y by itself and solve for y, what is the first thing that I'm going to do? Move the x. So what do I need to do to both sides? Minus x, okay. So notice this is still an equal sign. This is left over from yesterday, but it's going to lead us into today. So I have negative 2y equals negative x plus 6. Divide everything by negative 2, right? So what will that give me on the left? Just y. 1/2 x. I like that you said 1/2 x. What is the benefit of writing it like that? You're able to see the slope better. It doesn't confuse you, right? Because here's what you might have written.
Well, it's still right if you write like that.
Oh, yeah. It's still right if you write x over 2. Why is it positive, though? Negative divided by negative is positive. And x over 2 is not wrong, but because we're trying to see the slope easily, it's nice to write it as 1/2 x, because then you know the slope is 1 over 2. And then 6 divided by negative 2 is negative 3. So from what we did yesterday and the work that you just finished and graded in the back, which thing are you going to do first, the negative 3 thing or the 1/2 thing?
The negative 3.
Okay, that is your y-intercept. And then, bless you,
God bless you.
your slope is 1 over 2. Yeah, I was going to say the same thing. Weren't you the one that sneezed? I thought you were the one who sneezed. Up 1 over 2. Up 1 over 2. I also thought you were the one who sneezed. So y equals 1/2 x minus 3. Okay, that's a quick review of what we did yesterday. But, yes. You can do whatever you like as long as it's getting you the right answer. Yes. Shh, I can't hear the gentleman's question. For inequalities, yes. So that's what we're going to do now. So now moving from yesterday's work to today's work. These are your steps for graphing linear inequalities, right, instead of equations. Inequality is when it has less than, greater than, less than or equal to, greater than, equal to. So does this look very similar? Have you seen this before? Yeah. It's the same thing except one small change. What's the small change? It's not equal to. It's now an inequality. It has less than. So we start the exact same way. So what are we going to do first? Well, to solve for y. We're going to for inequalities. Right, which is what? Subtract the x, okay? Right, so now I have negative 2y less than negative x plus 6. And in the previous problem, what we did was we divided both sides by negative 2. But this is inequalities, so you have to flip the symbol when you divide both sides by negative. Bless you. So make a note to yourself somewhere if you won't remember that. Flip symbol when dividing by negative. It's a division sign. Flip this symbol when dividing by a negative. It's just a star. It's supposed to be a star. Let's just erase it. It's supposed to be. It's supposed to be like a tension thing or whatever. Okay. Yeah, so let's talk about the shading. So we transform to slope-intercept form. That's this part right here, slope-intercept. That was the first step. Second step, graph the line. Make sure it extends across the entire graph. So you're not graphing a segment, like with a start and a stop. It's a long line. It goes on forever. So you don't want to just start and stop at your points. You want to keep going, and you want to put arrows at the end. And you need a dashed line for less than or equal to, and a solid line if it has an equal bar. Will this be a solid or dashed? Dashed, right? So we start the same. We put the -3. We do our slope up 1 over 2. Technically, these should be open circles because it's not going to be equal to on the line. But I'm not going to be that picky about that. Extend it through your dots. Don't just stop at your dots because that's not a line. It's a line segment if you remember your geometry, which I do. And then put your arrowheads. Okay? That is a line. It's not very straight because I don't care. And then you have to decide which side you're going to shade on. And right here on step 3, it says shade below if it's less than, shade above if it's greater than. What do we have? What is this?
Greater than.
Greater than. So this is all the y's that are greater than the line. So this one's really easy to tell. When the line gets really steep, like it's like really almost straight, it's harder for students to decide where is above and where is below. And so I always tell them, look, just put your finger on the line somewhere, and you're trying to shade all the y's that are above. So if this is y equals 2, which way is y above that? And it's up here. So then you shade everything up there. And what this means is any point that you pick in the shaded area is a solution to the inequality. Okay? The stuff we did yesterday, the only solutions were whatever was on the line. But for inequalities, it's everything above or below. So it's like way more solutions. And if you wanted to test that out, do a test point. I always recommend 0, 0 as a test point because it's the laziest point to plug in because it's going to be so easy. Because if you plug, so 0, 0, by the way, is right here. Do we anticipate that that's going to be a solution? We do think so, right? Because it's in the shaded. Yes, it's greater than. So let's test out the 0, 0. I'm going to plug 0 in for x and y. So 0 goes in for x. 0 goes in for y to my original equation. And we're going to see if it checks out. Does this check out? Is it true that 0 is less than 6? All day long, right? So that checks. That means our math was good. Right. Done.